Hello and welcome back. In this episode, I'm going to continue playing with certain Kafka settings, and we will see how this influence the rotation of our segments, and we'll try to answer a very difficult question. For how long does Kafka persist our messages into the segment files? Please have in mind two things. Kafka doesn't delete a single message, instead it deletes a segment file, a log file. And another one, the mechanism of deletion depends on the cleanup policy of the topic. We'll see that in details. If you haven't watched the previous episode, then watching this one doesn't make really sense, honestly. And if you like what I do and how I do it, then you can support me in the usual way for YouTube. Thank you very much. We have a lot of work, a lot of experiments to do, so let's go. Now we're going to play with the segment milliseconds setting. It is similar to segment bytes, but instead of defining the size, which has to be reached by the segment before it is rotated, it defines the interval of time in which Kafka will rotate automatically our segment. For our experiment, I have set up this value to 10,000 milliseconds, which means theoretically that the segment will be rotated every 10 seconds, even if the segment byte is not reached. Let's start a cluster and see if this will work. We have to wait a little bit, and voila, the cluster is running. Now I will start a Kafka demo application, and it's also running. Now I can create a topic, and here we'll start watching what happens. I hope that you're able to see everything clearly. So this is our log. Currently it's empty. So in theory, if I publish something here and wait for 10 seconds, Kafka should automatically rotate it. Let's see if this will happen, or we'll have some kind of surprise. Yes, we already have this message here. It occupies some bytes, but even if we wait for 10 seconds or more, nothing happens. That is because Kafka will not rotate the segment before a new message arrives. So the expectation is that if I publish now the message, you'll see that Kafka will roll the segment and a new segment will be created. I can publish several messages now, and we have a new segment. You can see the second segment fills up with messages, and after about 10 seconds, a new segment is created. So we wait for 10 seconds. There is this segment millisecond condition is satisfied, and on new message, Kafka will rotate the log for us automatically. Okay, now everything is stopped, the cluster is not running, and we are going to have a small talk about the period in which Kafka persists our messages. This depends also on the cleanup policy of our topic. Perhaps you know that there are two cleanup policies, delete and compact. And delete means that Kafka will delete our messages after, for example, some amount of time. This amount of time is controlled by the setting retention milliseconds. So I will change the segment milliseconds with retention milliseconds and specify a value of 10 seconds for it, which means that our message will stay for 10 seconds in the walk, and then the walk will be rotated even if segment bytes is not reached, or even if segment milliseconds is not reached, then Kafka will still rotate the segment. These settings will overrule the other two, and eventually the segment with the messages will be deleted. Let's see how this works. Let's do some experiments as usual. So I will start our cluster now, and after it is running, I will go and start watching the directory of the newly created topic. Of course, I have to create the topic first. So I start the app, and then I will hit our create endpoint, which means that there should be already a new topic. And here I can start watching it. Hope you can see it clearly. This is the one with our first segment, where the first message with offset 0 will be stored. So I run this endpoint, and there is a message already here. You can see there are a few bytes within the log file. And then we have to wait for 10 seconds and see what will happen. After 10 seconds, you can see that we already have a new segment, so the segment is automatically rotated, and the old segment is marked for deletion. There will be some time before the segment is actually deleted, but now, since it's marked for deletion, we may assume that our message is not visible by any consumers. Finally, the message is really deleted. But let's make another interesting experiment. I will publish one message. Then I will wait less than 10 seconds. I will publish another message. And then wait again less than 10 seconds. And then another message. And then another message. So I will wait for 5 to 6 seconds and publish a message. So this waiting can extend quite a lot of time, and Kafka won't rotate the log. So this is the last message I have published. Now I wait for 10 seconds, and we'll see that the log file will be rotated. Let's give it a chance. Okay, now it is rotated, and it will be deleted. All old messages will be deleted, and the new messages will start to appear in this log, which is from offset 8. This seems a little bit complicated. That is why I'm going to visualize it. So let's have a look at this diagram. So imagine that this is our segment. It starts off at offset xxx, and the first message in the segment is published at time 0, at the moment of time 0, and the last message is published at the moment time 1. So after that, no messages are published in this log, and we have to wait a little bit, retention milliseconds. And after this period of time, the log will be rotated, and then it will be eligible for deletion. So the first message in our log may stay in the log file substantially longer than the last message. Nevertheless, that the retention milliseconds is, for example, this period of time, it will be applied only for the last message. The first message may stay longer than you expect in the log files. So how much time elapses in this scenario? We may see in this diagram. First, this is the amount of time t1 minus t0. Then it is retention milliseconds, or t2 minus t1. And finally, we have to wait even a little bit more before the retention check happens, because this happens in the background. And after the retention check happens, our log is rotated and marked for deletion. Even then, the message is still persisted in Kafka and is not deleted, but it is not visible to any consumers. It's not visible to consumers, but it stays at the disk, and it will stay persisted there for a little bit more time until the thread which is responsible for cleaning these deleted logs kicks in. Now let us see how this thing will work in case that our cleanup policy is not delete but is compact instead. I will shut down the cluster, and this application should be shut down also. And here we'll provide a new setting, which is cleanup policy. The value of the cleanup policy will be compact, which means that whenever we have two messages with the same key, the older message will be deleted. And I will delete, of course, this retention milliseconds here, because it makes not much sense. And here we will create a new endpoint, which will be able to publish a message with a given key. So let's go and quickly create this endpoint. I will name it publish with key, and the parameter will be key. And here I will copy this method, and we'll publish a single message with a specific key. I think I'm ready with the service, and I just need to change it here, and I have a new endpoint. And here in the request, I'll create a new request. Well, actually, I believe that we made a small bug here in this endpoint. That is because I left the key, the publish message with key, with random key. So I have to put here, instead of a random key, the key which I got as a parameter. Now I'm ready to start the Kafka cluster. I'm ready to run the application, and we have to wait a little bit for everything to be up and running. The application is all right, and the server will start up shortly. When we have this thing up and running, we can go to the craft combined logs, and before that I will create our topic with cleanup policy compact, and my expectation is that we already have the files here. And as you can see, we have an empty segment. Now what I will do is to put a key here. This one starts with AF62 whatever. And what I want to do is to publish one message with this key, then 3 other messages. And finally, the 5th message will be with the same key, which means that this one should be deleted by Kafka. Will this happen? We will see. First, this message is published. We'll see that something happens, something moves here. Then we publish 3 more messages, and finally the 5th one. So currently we are here, and our log file has these 5 messages. Now, normally we should expect that Kafka will delete the first message, but Kafka, as I have said, Kafka never deletes a single message, it deletes a whole segment. And this segment, our currently active segment file, is not yet rotated. It's not yet rotated because we deleted the segment millisecond setting. That is why it stays like this. Something will change only whenever we have our segment rotated. And here we will be able to rotate the segment if we publish more than 10 kilobytes. That's why I will publish, for example, 60 more messages. So 60 more messages are published, and you can see that we have our log file with this size. And we have to wait for a few seconds, and you can see that something strange happens. New log files appear here, but this time it is a little bit shorter. As you can see, a couple of bytes shorter. And the previously active segment is marked as deleted. It will stay for some time as deleted until the thread that is responsible to clean up these files is activated, and these files with suffix deleted disappear. Why this segment is smaller? Because what Kafka did is that it created a new segment file, which is with this message, with the first message deleted. We can verify that if I come here and try to dump the segment. At the top, you can see that the log starting offset is 0, but the base offset of the first message is 1, which means that this message with offset 0 had been deleted. Now, to elaborate a little bit more, currently we have in our, so these deleted files with suffix deleted were already removed, and currently in a 00 log file we have the following content. We have a couple of messages, we have our message here, and we have couple of more messages, and now we have the work file with 59, and we have a couple of more messages in there. Now let's publish one more message with the same key. So here we go, and it will happen that this segment contains one of the messages with this key, and this segment contains such message. So now if I publish a little bit more messages, you see that we'll create a new segment, and what will happen is that the message which is located in the first segment, so this 00, should also be deleted. As you can see, this happened, and we also have surprisingly the segment with offset 59 also marked as deletion. But this is an implementation quirk because, as you can see, both segment files have the same size, so they are absolutely the same. This is just an implementation feature or quirk of Kafka nothing actually happened in this segment file because it shouldn't be compact. It contains one message. This work file was compacted, so this message was practically deleted. Nothing happened here. We have our message still here, and we have a new segment which is currently active. So what is in summary, what happens when we have topic cleanup policy compact? It happens that every time when we rotate a segment, Kafka checks if there are some messages which can be potentially deleted. It creates new log files without these messages. It marks the old log files for deletion, and a thread kicks in and deletes the log files which were marked already for deletion, but new log files based on the contents of the old ones were created. So in fact, the size of our segment gets lower and lower the more messages, the more the messages are compacted. It sounds a little bit complicated, but it's in fact not so difficult. So that was everything for this episode. If you like what I do, then please like, share, subscribe, and I hope to see you in another video.